is designed to operate like a stratospheric satellite to provide affordable persistence over any spot on the globe. This is not latitude restricted. And by switching position with another Global Observer airplane once every 5 to 7 days, we intend to provide uninterrupted, seamless coverage 24/7, 365, or as long as our customers need that capability. The idea is this will be carrying different kinds of payloads, ranging from ISR to communications relay to other kinds of payloads. And because it's basically a platform with a payload capability, customers will be able to integrate, or we will be able to integrate on behalf of customers, a variety of payloads based on the mission requirements. Flexible, affordable, persistent. Key attributes of the Global Observer system. So with that introduction of the company and the program, I'd like to turn it over to Bob Curtin, who's going to go into a little bit more detail about the development program to date and show you the first public viewing of our first flight.
Thank you, Steve. Just want to talk a little bit about the JCTD and what we've been doing over the last 3 years. The contract that we're under right now started in September of 2007. And so we've been going on this contract for a little over 2 years, almost 3 years now. About midway through the contract, we did multi-day power plant tests at altitude with our power plant for Global Observer. So we've done multiple 7- and 5-day tests at altitude. Big milestone for the program. We started ground test this calendar year of the first Global Observer. And you may have seen a press release recently on our wing load test that we just completed out at NASA Dryden. And we're in flight test now with Global Observer at Edwards Air Force Base. Just a little, very simple diagram of what Global Observer is, what its propulsion system is. It's fueled with liquid hydrogen that's burned in an internal combustion engine that spins a generator. Generator makes electricity for the power plants or the motors that spin the propellers. And then there's a battery on the bus also that provides backup in case the motor has a problem. So in concept, very simple, but the technology behind the motors and the generators has been in development for at least almost 30 years. And we flew the airplane. We're in flight. We've been flying for about a month now. Actually flown the airplane 3 times. 2 flights of an hour each. And you're seeing the flight here on August 5th. The flights have met all the objectives set out for the flights, very successful. Our first long flight was testing the handling qualities of the airplane. It handles quite well, it's well damped, the pilots like flying it. Second flight was used to test automatic flight control modes. So modes like heading hold mode, turn rate hold, airspeed hold, that sort of thing. So this is in flight near Edwards Air Force Base. Got up to an altitude of about 2,000 feet above ground level in these initial flights. These flights are on battery power right now. We'll conduct a few more flights on battery power, and then we're going to integrate the hydrogen propulsion system and start flying on that in a few months. During descent here, the motors turn into windmills, which increases the drag on the airplane, allows the pilot to control glide slope on landing. That's its first landing. And with that, I think I'd like to turn it over to Roy Benson.